So this video brings us to cross-tabulations as a statistical tool you use in particular circumstances. When you think about the different tools that you need to use, you have to be aware of the context of the measurement and the kind of measurement used to be able to use the right tool and make the right conclusions about what you've learned. There are a series of videos that have been already recorded and are available at the same channel that are necessary. You have to understand them before you can understand this one. You need to understand the framework for applied statistics, which I'm using as my way of framing how you might make direct, immediate statistical decisions about which tool to use, how to interpret the results, how to find the right results to make your answers from, and how to write up or present your results so that you answer the original question. You should look at the introduction to JASP if you're interested in using the free statistical analysis software package that I'm using in this video. You should look at the distributions video for an introduction to how distributions work, because fundamentally cross-tabulations, also known as contingency tables, are at root comparisons of distributions. So many of the things that are talked about in that video are carried forward into this one, into a more complicated application of distributions. Also, that video has some discussion of the way that you might present the results in a template form and how you might put different pieces of information down to answer it. I won't go back over that in this video again. You might watch the shape, strength, and significance video, which basically says if you're moving to bivariate analysis, what does it mean to talk about the shape of the patterns, the strength of the patterns, and statistical significance of the patterns. And I'm simply going to carry on assuming you know that in this video. So those 4 videos that have preceded this one, I'm assuming you've watched them and you have a basic understanding of them when you move into this one. So the framework that I'm using basically tries to help you to choose the right tools with a very simplified choosing grid, helps you to figure out what kinds of things you should be reporting on to be able to answer questions, and suggests 5 guidelines for ways that you try to actually present or write up your results so that you can answer questions. That full framework is the surrounding basis within which I will use cross-tabulations. Now, you always start with some kind of analyses questions. I'm not going to try to hypothesize a work setting or some other particular applied context. I'm simply going to say that we just find that we want to know, what do people think of spending on national defense? Or what do people think about satisfaction with our product? What do people think about policies to change particular kinds of policing patterns? Whatever it may be, we have some survey data. What do people think of spending on national defense? I also want to know, do people with different political views, that is, more liberal, more conservative, have different views on spending on national defense? And do men and women have different views on spending on national defense? I'm going to use the 2018 General Social Survey data that I've talked about in a couple of these previous videos already, and the variables I'm going to work with specifically are Nat Arms Y, which is about what do you think about people's views of spending on national defense. I'll show you that more in a second. I'm going to use the variable that was added to this by the ARDA. It's a data archive that just cleaned up a version of political view that's already in the data set and got rid of some missing data, collapsed some categories, so it's ready to go as a simple version of the variable. And I'm also going to use the cleaned up sex variable that has male and female and is ready for us to use. Okay, so here's the dependent variable. We are faced with many problems in this country, none of which can be solved easily or inexpensively. I'm going to name some of these problems, and for each one I'd like you to tell me whether you think we're spending too much money, too little money, or about the right amount. First, national defense. Are we spending too much, too little, or about the right amount on national defense? And some sample within the sample of people asked to participate in the survey answered this question. And then they were also asked, We hear a lot of talk these days about liberals and conservatives. I'm going to show you a 7-point scale on which the political views that people might hold are arranged from extremely liberal, 0.1, to extremely conservative, 0.7. Where would you place yourself on this scale? Now, the version used in this example is one that has collapsed liberal and extremely liberal together. Then we have a category for slightly liberal, a category for the moderates, a category for slightly conservative, and a category that has put conservatives and extremely conservative together. And then finally, I have a variable that basically asks people their biological sex. Are they male or female? So this first question, what do people think of spending on national defense? That's a univariate question, and it was explained how you would answer that, what you would do with that in the distributions video. But these next two, do people with different political views, do men and women, have different views on spending on national defense? This is something new. This is what we need to use cross-tabulations for. If we go back to the framework, one of the things we have to decide is, are we doing a one-variable analysis, which is to say we're just going to look at the patterns in each variable independent of the patterns in any other variable? Are we doing two-variable analyses where we're going to see if the patterns in one variable is they are mathematically related to the patterns in the other variable, which means you normally either have a predictor and an outcome, or if you're thinking they might be causally related, you have an independent and a dependent variable. And while I'm using those terms interchangeably in this series of videos, they do mean conceptually slightly different things. But since I can't know for sure what you might want to be working with, I'm just using them interchangeably to keep reminding you both sets of terms are in play. And you could be doing a simple multivariate analysis where you say, does this particular variable relate to, the patterns in this variable relate to the patterns in this other variable, an independent and dependent, having controlled for the effects of something else? Well, in this circumstance, I'm trying to find out if male, female, in some sense is related to, perhaps we're asking if it actually causes view of spending on national defense, and I'm asking if liberal conservative relates to or possibly causes views on spending on national defense. So what I'm working with here is I'm working with a two-variable analysis. I have three variables I'm talking about, but I have one variable being related to views on spending on national defense, and then I have another variable with the patterns in it, male-female, being related to views on spending on national defense. There's nothing I'm suggesting here that puts all three of them together in one mathematical formula. Okay, so we're going to be in that row. Whatever tool we're going to use, it's going to be somewhere in that row. And then we ask ourselves, the dependent variable view of spending on national defense, is it categorical? People are put in discrete answers, yes, no, whatever. Or is it scaled? They'll be on some scale like the measure of a GPA in a school where you go from 0 to 4. Well, this is an ordinal variable view of spending on national defense, and so it is in fact categorical. So we're going to be in that column. So let me just drop the choices from that column into the framework, and you see that the choice we're going to work with is cross-tabulation. If we had had some other variables involved, then we would have ended up somewhere else in the table. All right, if we're doing anything that's two-variable analysis, we're going to end up needing to talk about shape and strength and statistical significance to be able to effectively answer any questions. All right, one more thing needs to be talked about if you're going to do cross-tabulations. Most other tools don't run into this problem. Some do, but most of them don't. But this tool, it depends also whether you have a nominal or an ordinal table. Okay, these are rough terms. They're not. Don't take them too literally, because it's not saying what you may think they're saying. A nominal table doesn't really mean that every variable in the cross-tabulation is nominal. It just means that there is a nominal variable somewhere in the cross-tabulation. Either the independent or the dependent variable is a nominal variable. So if either variable is nominal, we're going to call that a quote-unquote nominal table. An ordinal table is going to be a table where neither variable is nominal. Or you could say when both the independent and the dependent variable are ordinal or higher. So it could be interval, it could be ratio, but in some sense, this is a variable that works categorically in cross-tabulations, and in some sense, both variables are better than nominal measurement. That's going to matter because what tools we use will be affected by this. So nominal tables, there is an assumption that you will have at least 30 cases in each category of the independent variable. And you will need at least 5 cases in every cell. It's called the continuity assumption, and it has to do with something mathematical that if you want to learn more, you can learn more. But at this point, to just choose the tool, you simply look inside the table, the cross-tabulation of the frequencies, when we look at a table in a moment as an example, and we say, do we have at least 5 cases in every cell? If we don't, then we can't, if it's a nominal table, we can't move forward because we're violating an assumption that underlies the mathematics that makes this analysis work. All right. Needing 30 cases in each category was talked about in the distributions variable video, so you can go back and watch that if you wish. Now, we need to talk about shape, strength, and significance, we said. So we find shape in a cross-tabulation by using the percentages within the categories of the independent variable. And then we compare and contrast the distributions within the categories of the independent variable to describe the shape. Now, I'm not going to explain how or why we come to this. I'm simply telling you this is what you use in cross-tabulations in a nominal table. If you're looking at the strength of the relationship, then you're going to use a tool called Cramer's V. There are others, contingency coefficient, lambda, several others, but honestly, all of them have one or another limitation, a circumstance when they're less likely to be useful or can't be used at all. Cramer's V is the most robust tool. It can be used in the most circumstances. Whatever you might be doing in a nominal table, Cramer's V pretty much always works. So it's the tool that we tend to choose, and it's the tool that almost every stats program, well, every stats program I've ever worked with provides Cramer's V. We're going to explain more about what you do with Cramer's V in a later slide. Statistical significance, as was said in the shape, strength, significance video, what you end up looking for is a p-value that tells you something about the probability that we could have found the results we have from the real world survey data, or whatever data we're working with, even though the null was true. So certainly if we find in the real world survey data the null pattern, we would say, well, that would suggest certainly the null could be true for the population. But as what we find is more different from the null pattern, as it moves away, we say it's less and less likely that the null could be true in the larger population if our sample data has something that's different from what the null predicts. So as we move further and further away from the null pattern, we tend to say there's less and less chance the null is likely to be true. And this p-value is the probability that the null might be true, having seen the real world data that we do in fact have. So in this circumstance, you're going to look for in a nominal table a p-value that's associated with a tool called chi-square. Let me clear my video here. Or you're going to use a p-value that's associated with, you'll find it right next to Cramer's V. Now it's the same p-value because the p-value that is constructed from either of them is based from the same underlying probability mathematics. So normally what you do is you just tell the stats program you want Cramer's V, and you look at the p-value that comes beside it. Okay. Now, there we go. Now to look at ordinal tables, you do still have the assumption that you need at least 30 cases in each category of the independent variable. However, the continuity assumption that was in the nominal table that was underlying the tool chi-square isn't as important in this case. Now you still look for shape using the percentages within categories of the independent variable, but now instead of simply doing compare and contrast, you tend to do direction of effect, positive or negative. And I'm going to talk about that on a later slide, but even more, I talked about direction of effect. I'm going to talk about it really more in later live analysis, but it was discussed in the shape, strength, significance video. So I'm assuming you understand direction of effect when we move into this. If you have to, you can fall back to compare and contrast, but compare and contrast descriptions of patterns, it's messy, it's murky, and it doesn't really help your audience to feel as confident that they know what they've learned. But if you have a nominal table, you have no choice. Compare and contrast is all you can do. But if you have an ordinal table where both variables are measuring amount in some sense, and they're both at least ordinal or higher, then you can actually have a direction of effect. Significance is going to be the p-value that's associated with tau b. Oh, I guess I skipped strength. Tau b is what I recommend. Now, tau b, more about that on a later slide, but tau b assumes the table is roughly square. Saying a table is square would mean that your independent variable has roughly the same number of categories as your dependent variable. So if it's a 3 by 4 table, it's a rectangle, but it's roughly square. If it's a 2 by 35, you have male, female, and then 35 categories in the dependent variable, then you're a long way from a square table. It's a very stretched out rectangle, and tau b isn't your best choice. But I'm going to stick with tau b because it's fairly robust. You can get a ways off of being a true square cross-tabulation and still use tau b. And the other tools that are available to use with ordinal tables, they all have limits of one sort or another as well, and those other limits are, in most circumstances, more troublesome than simply using tau b. But if you find that you have a table that has lots and lots of categories in one variable and only a few categories in the other variable, you're going to need to not use tau b, and you're going to have to think about whether you should take that variable that has many categories in it and just collapse them together into a few categories so you get a table that's roughly square. Okay, so let's talk about shape. I said you're supposed to use the percentages in the categories of the independent variable. Now, crosstabs can have the independent variable on the rows or on the columns. All this is going to be demonstrated in live analysis in just a moment. But you're going to have to think about which way you've put your independent variable into the table, and you're going to have to do the percentaging that creates percentages within the categories of the independent variable, be that on the rows or on the columns, whichever is appropriate. You look to basically see that percentages add up to 100%, add up to 100 within the categories of the independent variable. So when you're reading someone else's work, you have to look at the table and say, which way do the percentages add up? Do they add up to 100% across all the rows or down all the columns? And that's how you figure out which variable is predicting which variable. And this matters because which way you percentage a table completely changes what the table tells us. I'll show some examples of that in a moment, but you really have to be careful with this. Probably the most common error I see people make when they're novices and they're having to do some kind of work is they percentage the table the wrong way, or they read the table as if it's percentaged differently than they've actually done it, and they make grievous errors in understanding what they're seeing. In fact, they just make nonsensical claims. Okay, so now let's look at some live examples of this. Let me drag JASP over into the capture window. Now, what I have here is the 2018 GSS I've been working with in the previous videos. This particular version of it, I brought it in as a CSV file and then I saved it as a JASP file. I went into the hamburger menu here and I did the save as, and I saved it in a particular place, and I saved it as a JASP file. Okay, so now when I open it as a JASP file, it saves any of that data set work I've done on it. In this particular circumstance, what I've done is I've gone into the data set, and for example, here's my dependent variable for this analysis. I went in and I entered too little, about right, and too much for the 1s, 2s, and 3s, and you can see it reflected in the column that that's what it's doing now. That's so that when I read the tables, those labels will be on my cross-tabulation and make it easier to work with. Similarly, I have inserted at the very end of this file, I have inserted the labels for the particular variables that we're working with. So this view of political liberalism or conservatism, I have entered the labels in, and likewise for male, female, I've entered the labels in. Then when I saved it as a JASP file, it keeps those, and it will store those every time I do it. Now we also need to remember that in the spending on national defense, as was talked about in an earlier video, there are missing, that is non-valid categories. If a person in that that variable has a value of 0, it means they weren't actually even asked the question. It's not an appropriate question for them. If they have a value of 8, it means they volunteered the answer, I don't know. And if they have the value of 9, it means that they, on their own, said, I'm not going to answer that question. All right, so I have to go in and make sure that my preferences for the data includes missing values of 0, 8, and 9. And I've already entered those in. It's all saved up. That's great. But remember, the 0, 8, and 9, those values are now taken out of all variables. So I have to make sure that my politics variable, 1, 2, 3, 4, 5, no zeros, no 8s, no 9s, I'm good. I have to make sure that it has no 0s, 8s, or 9s, and I have to make sure that sex didn't use, like, it could say male is 0, female is 1, or whatever. In this circumstance, they actually have 1 and 2. So that's great. Otherwise, I would have to go into the data set and I'd have to change some code numbers so that they didn't hit those missing values. You always have to make sure you're only removing the missing values that you mean to be missing in just the variables you mean to be removing those values in. All right. So if I go to the frequencies pull-down menu, there's a variety of things here. Contingency tables is another name for crosstabs. And so I'm going to do some contingency tables. I'm going to go down here to my dependent variable that I've already discussed. It's the 121st variable in this data set. And I'm going to put it on the rows. Now, I could put it on the rows, and I could put it on the columns. All right? But I'm going to put it on the rows, and I'm going to then go to the end, and I'm going to put the politics variable on the columns, and I'm going to put the sex variable on the columns, because those are the two tables that I want to run. So it's putting in the labels for my independent variables, but not putting in the labels for natural arms Y, because I just labeled those a moment ago and I didn't save the data set before I ran this, but that's fine. We'll remember what a 1, 2, and 3 are in this circumstance. All right. Now, I could have, instead of putting it together this way, I could have put the spending on national defense, I could have put that on the columns. And I could have put these independent variables on the rows. There's nothing wrong with doing that. By custom, most of us who build cross-tabulations, we tend to put the independent variables on the columns. You see, the categories of the columns are the categories of the independent variables. Male, female, different kinds of political view. We do that because for most people, especially in cultures from the West, you tend to read from the left toward the right, and so you look at what's true for this group, and then you compare it to what's true for this group, and you compare it, and so you're comparing these distributions as you move from the left to the right. So we normally put the independent variables on the columns. If you choose to put them on the rows, you just have to change this next step. So I've put the independent variables on the columns, and so now I'm going to go into the cells, and I want to put in percentages because I'm supposed to, for shape, look at percentages within categories of the independent variable. Well, I have my independent variables on the columns, so I'm going to use column percents. All right, so now when I look at this first table that has political view, I can see that for those who are extremely liberal or liberal, that group of people who were answered either extremely liberal or they answered liberal, 12.9% said too little is spent on national defense. 34% said about right is spent on national defense. And 53% said too much is spent on national defense. As I move to the slightly liberals, it goes to 21, 37, 42. If I go to the moderates, it's 29% saying too little, 44% saying about the right amount is spent on it, and 26% saying that too much is spent on it. Now, when I move to the slightly conservatives, 38% say too little, 40% say about the right amount, 22% if you're using the even round rule, 22% say too much. When I move to the conservative or extremely conservative, 46% say too little is spent on national defense, 43% say about the right amount is spent on it, and 11% say too much is spent on it. Now, what's the shape? This is an ordinal table, so I'm supposed to be looking for a direction of effect. as people, here's what you end up having to ask. What is this political view question measuring? And I'm going to say, if I was going to draw an arrow on it of increasing, I draw it to the right and say it's measuring going from least conservative to most conservative. If you want to treat it as a measure of liberalism, it goes from least liberal to most liberal, you could do that too. But I'm going to read it as moving from least liberal to most, from least conservative to most conservative. And so as you move to the right, as you have more conservatism in your political view, what happens to your views about spending on national defense? Well, we could pick whatever row we wanted to. You'd kind of have to look across the table and think about which rows are going to help you the most. But you can see that the extremely liberal and liberal tended to be gathered up as spending too much. And then you can see that too much goes from 53% down to 42, down to 26, down to 21, down to 11. As people become more conservative, they actually tend to say too little. 13%, 21%, 30%, 39%, 38% with even round rule, and 46%. So as people become more conservative, they are more likely to say too little is spent on this, which would be, if I reported it that way, I could say that there is a positive relationship if I want to write it that way. But basically, whether you say positive or negative, in words, when you want to describe this pattern, right, you want to say, as people become more conservative, they tend to shift this way on their views on spending on national defense. That's the pattern in words. As people become more conservative, they tend to be more likely to say too little is spent on national defense. As people become more liberal, they tend to be more likely to say too much is spent on national defense. In words, that's what we would use. Now, for the shape, how many of these percentages do we need to quote in our reporting to justify that? Well, it depends on the table. It's murky and it's messy working with crosstabs. It's one of our least favorite tools just because you end up having so many numbers involved. It's hard to know which ones to report. And you want to report enough numbers that there's a full transparency of the pattern, not just enough to support your claim of what you think it says, because then you can cherry pick numbers and hide other things. But you report enough numbers that anybody looking at it can decide what the pattern is and see if they agree with what you said in words. I think you'd get by just fine if you said, as people become more conservative, they are more likely to say too little. Then you could just say 13% said this, 13% of these folks said too little, 21% of these folks said too little, 30% of these folks said too little, 38% of the folks who are slightly conservative said too little, and 46% of the people who are conservative or extremely conservative said too little. And I think with those 5 numbers, I have fully made transparent the shift. I'm not hiding anything from any of the columns. It didn't go from 13% to some really big number, down a number, up a number, down it. I'm not hiding any movement up and down. I'm giving you all the numbers that show the percent that said too little. And as you become more conservative, a larger percent of people say too little. If I had said as you become more liberal, you're more likely to say too much, I would have probably chosen this row along the bottom. And I would have talked about going from 11% to 22% to 26% to 42% to 53%. So you choose enough numbers to be fully transparent about the pattern and to evidence your claim in words so people can see if they agree with the way you've written it in words, and then you stop. You don't need to give all of the numbers here. You don't need to give all 15 of the percentages here. Okay, let's stop for a second and go back. I should have done this to begin with. Do we have enough cases in each category of the independent variable? We needed 30 cases or more in each category of the independent variable. We have 210 extremely liberal or liberal, 116 slightly liberal, 403 middle of the road, 135, 205. We have plenty of cases in each category. Do we have at least 5 cases in each cell? Now, this is really only something we care about for nominal, but it never hurts to just get in the habit of checking these things. And if you look across the table, you find that we have plenty of cases in every cell to even meet the chi-square test that would be used with a nominal table. Okay, so that's the shape. Now let's look at the shape in the sex crosstab. So this one, we have a nominal variable and we have an ordinal variable. Because one of the variables is nominal, now it's a nominal table. This one was an ordinal table. Both variables were ordinal or higher. Now we have a nominal table. And now with the nominal table, all we can do is compare and contrast. We can't say, as you become more female or as you become more male, just with nominal variables, avoid using that kind of language and just say, here's what it looked like for the men. 29% if I'm rounding, 29% said too little, 39% said about right, 32% said too much. And here's what it looked like for the women. 33% said too little, 42% said about right, and 25% said too much. And so now I compare and contrast. Is the distribution for the men a lot like the distribution for the women, or are the two distributions quite different? Well, I have 29 and 33. I have 39 and 42. I have 32 and 25. They're more alike than different, right? When we were up here and we went from 13 to 21 to 29 to 30, if we even round rule, to 38 to 46. We went from 11 to 46. That's a lot of difference. Here, we're going from 29 to 33. That's not a big difference. They're both right around 30. And here, 39 to 42, they're right around 40. And here, 32 to 25, they're basically right around 30. All right, so these are more similar than different. And now it's harder to decide how many percentages you have to report when you do a nominal table, because I'm going to say men and women had basically the same pattern. And I'm going to have to give probably all 6 numbers to really make that transparent. Or I could just pick a few if I feel like the audience is going to give me latitude to just report enough to show them some numbers. All right. Now, strength, we said, for, let's stay down here with the nominal table, strength was going to be from a tool called Kramer's V. So here's phi and Kramer's V as an option. I'll turn it on. And it's going to report it now for all the tables, but I just want to use it for the nominal table. So here's Kramer's V, and it's 0.079. Now, in the shape strength significance slideshow, I talked about interpreting Kramer's V. And Kramer's V of 0.08 is just under a very weak. There's really nothing going on here. We wanted at least 0.1 before we decided that we had a very weak relationship. We wanted 0.2 before we said it was a weak relationship, much less moderate or strong. So this really falls in the there's no relationship here. Being male or female doesn't seem to affect, or at least doesn't mathematically predict, view on spending on national defense. So there is no relationship here. If you want to say it's very weak, and it's not even quite, it's at 0.08, not even at the 0.1 threshold I gave you in that other video as a rule of thumb. You could claim it's very weak, but most of us who know this would kind of say, well, yeah, very, very weak. So when we look at this, we end up saying we see that they look alike, and we see that basically there's no strength because they look alike. Strength is a measure of how different they are. All right. So what's the basic trend in the relationship of the patterns here? Well, we found that as you become more conservative, you tend to be more likely to say too little. As you become more liberal, you tend to be more likely to say too much. Okay, so that being so, how strong is the relationship? Well, this isn't the right tool. We wanted to use Kendall's Tau B, and you even see they're named here, nominal and ordinal, in your selection options here in the stats program. So we're going to go to Kendall's Tau B. I'm going to go ahead and get rid of that Kramer's V. And now I'm just looking at Kendall's Tau B, okay? And now I'm going to look at Kendall's Tau B, and it says it's a negative 0.282. Okay. So crosstabs. They're not our favorite tool. They're really clunky to work with. In all the later tools that we talk about, when you have a negative or a positive sign on a measure of strength, a measure of association, or a measure of correlation, and those terms don't all mean the same thing, but roughly they're analogous to each other in what they accomplish. They're all measures of effect, size, or strength. if you look at this measure of association, if it has a negative or positive, it's supposed to tell you the direction of effect. It's supposed to straight up say this is a negative relationship. As you have higher on one variable, you tend to get lower values on the other. And what it's doing is it's just looking at the literal numbers. As you go from a 1 to a 2 to a 3 to a 4 to a 5, you tend to go from 3s to 1s. So as you move up in terms of political view, in the actual code numbers used, 1, 2, 3, 4, 5, as the number gets higher, you tend to move lower. So it gave us a negative Kendall's Tau B to tell us there's a negative relationship here. But you gotta look. See, the problem is that if they built this survey, if they just wanted to, they could have had a 1 stand for too much, and a 2 stand for about right, and a 3 stand for too little. Surveys can code their answers any way they want. So you really need to read the table shape and get the direction of effect from reading the table, not from that sign on the ordinal measure of association. With our later tools, Pearson's R and some other kinds of tools like that, we will trust the sign, but not this one. This one you have to actually think about whether that sign shows what you want it to show. Doesn't matter what the sign is, though, negative or positive, 0.282, we decided in the shape strength significance video, 0.282 is a weak relationship. It's almost a moderate relationship. It almost makes it to that 0.3 cut point. So I'm going to say that, yeah, there's a difference going on here. And it's a weak difference, but it's real. It's something that's going on here, okay? And I could even claim 0.28, 0.3, close enough. I'm going to call it moderate. These rules of thumb for these cut points are rough, and we don't all agree. Professional statisticians don't agree by any stretch on where these magic cut points should be. But this is clearly a real pattern that's going on here. So, that being said, we would expect that when we look at statistical significance, we will find that it is significant because this looks really different, maybe even moderately strength different, away from what the null would predict, because the null predicts that all the categories of the independent variable are going to have the same distributions in them. That's what the null predicts. So when we look and we say, well, we're going to look at the p-value associated with the strength, that's what I had suggested you would want to do. So it's p is less than 0.001. Well, the general custom in the social sciences is that if that probability is less than 0.05, then we're going to say it's statistically significant. This one's less than 0.001, so it's clearly less than 0.05. So we have a clear pattern. The more conservative you are, the more likely you are to say too little is spent on national defense. It's a weak to moderate strength effect, and it is statistically significant. We can reject the null. We're pretty confident that we can reject the null that claims really there's nothing going on here. We just have some sort of mismeasurement or bad sample. Okay, let's go back and put Kramer's V back on. So I can go back down to the the national defense spending by sex. And now we saw that they looked a lot alike. The answers that males gave looks a lot like the distribution of answers that females gave. And we find that that's supported by the strength number that says basically this is, oops, not Kendall's Tau B, Kramer's V, thank you, that this is 0.08. It's really, there's no relationship. And then we look for the statistical significance, and in a nominal variable, we use chi-square. In fact, Kramer's V is calculated using chi-square in it. And so we have 0.03, okay? So 0.03 is less than 0.05, and we could say we can reject the null hypothesis. So we can say that, but we probably would want to be cautious about overclaiming here. They are a little bit different. It's so weak that it's below very weak. We can reject the null and say that the null that they look exactly alike isn't true, but we're not really very confident that there's much going on here. Okay. So once you've done this, let me actually show one last thing. We've done this correctly. Let's get rid of the sex variable. Let's just work with the political view one for a moment. Now let me do something wrong and show you what happens when I do something wrong. instead of using percentages in the categories of the independent variable, I'm going to percentage within the rows. Now, I'm going to shift back and I'm going to talk about these. So here's the column percents, and we said for these people, extremely liberal or liberal, 13% gave answer 1, 34% gave answer 2, and 53% gave answer 3. When I go to row percents, and now it adds up to 100% across each row, right? You see it adds up to 100% here. Now I'm saying amongst those who said too little was spent, 8.5% of them were extremely liberal or liberal. 7.6% of these people said they were slightly liberal. 37.5% of these people. What we're doing is we're positing this as the independent variable. And it reads entirely different. So now I can't percentage like this and then say, well, here's what the extremely liberal or liberals folks think. That's not what this shows. This shows the political affiliation of people who gave this answer, okay? And you can see that these numbers don't look like what you might at first expect them to, because the row percents are not doing what we were meaning to do with the question we asked. We asked, does political view predict, maybe even cause, answers on view of spending on national defense? Now that I've put it in row percents, I'm now saying that does view of spending on national defense predict or maybe even cause political view? Did people choose this stance and that led to them adopting a particular political view? Which isn't the question we asked. This is the wrong way to percentage the table. The percentages are entirely different. You have to percentage within the categories of the correct variable, the independent variable. Now, Kendall's Tau B doesn't care. The way it's calculated, it doesn't care which of these. It's called a symmetric measure. It doesn't care which is the independent and the dependent. It's going to give you the same result. But this set of percentages, if you ran this, would actually not answer the question that we posited. The question that we posited asked to know if political view, if people gathered in political view categories, if that in fact predicted, or maybe it even is a reflection of a cause of them choosing particular answers. Okay, so this leaves one last thing we want to jump back to. Let's go back to our table here. Okay, so what if you wanted to present this as a graphic form? Here's a stacked bar chart. Now these are vertical stacked bars instead of horizontal stacked bars like I used in the distributions video. And there are a couple of things that need to be pointed out here. If you looked at this and you looked at the stacked bar charts for the distributions video, they would look very similar. They're all stacked bar charts. But in the distributions video, each stacked bar chart was the distribution of people's answers on a single variable. So what was their view of spending on national defense? What was their view of spending on space exploration? What was their view of spending on whatever the topic would be? And there were a bunch of them. These bar charts, which I have done vertically simply to have you see a way to compare them to the horizontal ones, but there's no rule that crosstabs are vertical and distributions are horizontal. I just did that so that when you look at them, you'd see something was different. But if you look at this, now it's the distribution for the men on view of spending of national defense and the distribution for the women put side by side. You actually have categories of an independent variable that identify each stacked bar, instead of it being a series of separate variables. So go back and forth between the distributions example and this crosstabs example and gain the ability to see which one you're seeing. Now, look at that graphic and tell me if you see much difference between the left stacked bar and the right stacked bar. What you have here is this light blue is indicating too much is spent on national defense. The medium blue is about the right amount is spent on national defense. And the dark blue indicates that too little is spent on national defense. And this is for men, and this is for women. And you can see that they're a little bit different, but not a lot. This might work better for a lot of audiences to see this graphic and for you to say, look, the pattern of distribution for the men, the pattern of distribution on answers to spending on national defense for women, they are basically the same. And you look at that and you say they're basically the same. But now look at this one. So this is view of spending on national defense within categories by political view. And now you look at that and you say, there's a really different pattern going on here. And I can see as I move to the right, there is an increasing amount of the dark blue and a decreasing amount of the light blue. This shows a clear pattern. And people looking at this, whatever audience you're working for, people looking at this can see it. Now, you might ask, Steve, do you have something against other colors? Well, if you've seen the distributions video, I already gave you that answer. Let's imagine that you're sending this to people as a PDF, and they're looking at these colored stacked bar charts, and they then want to print it off, and they only have a black and white printer, which at a lot of places, that's all they have. Or they don't want to spend the money on color printing. When they print this off, I will have shades of black and gray. But if I actually had all the bars different colors, one was blue, one was red, one was orange, they might actually all come out roughly the same color of black, and you just have one big black bar for every group, for every category. And it wouldn't translate into something visible once it's printed. So it's more ugly in the visual presentation of the colored, but it works as a printed black and white. Or it's useless in the printed black and white, but it looks much better in the visual color. So you just have to decide what it is that you're trying to accomplish with the graphic. All right, so when you go to do cross-tabulations, in sum, you need to figure out what questions you're trying to answer and what variables you're using, figure out the levels of measurement of the variables, figure out the kind of analysis, one variable, two variable, or simple multivariate, and you need to find the right tool. This would be crosstabs for the kinds of data we're looking at here, categorical dependent variable. And then you need to look at shape, strength, and significance. And if it's a nominal table, you're going to do it in one way, and you're going to include Kramer's V. And if it's an ordinal table, you're going to do it in a slightly different way that uses direction of effect. And for measure of effect, it's going to use Kendall's tau B. All right. That's the introduction to cross-tabulations. It's one of the clunkiest but most commonly used tools out there. There are a lot of people who just in the regular day-to-day job, they end up using crosstabs because they have simple satisfaction data from the clients, simple measures of different things that are usually kind of survey-based, categorical kinds of data, lots of nominal and ordinal variables. And cross-tabulations, unfortunately, it's the only game in town. The later tools we're going to look at are much easier to work with in terms of seeing how to use the results to answer things. Although, it's much less intuitive how in the world they work. We'll turn to those tools right after we stop and take a look at specification by itself and then look at controlled crosstabs.